شلام لوخن أنا ريبيكا سايمون مجيبت يداء شاميران قابل لوخن ون بشينا وديو بتهمزمخ باسط خادنا ديفايس قد تازا بشت لبريتا إلى بشمت Ventilation Assistance Device قد كهايرا قدنا ناشي قد لنا باشور راحت نفس كرشي قدنا داناتي قد أخنن اتلان خادنا فيروس كوفيد اتجاسر قد رابا ناشي مراني نفس ليلة بلاطا أهد ديفايس رابا إلى هايرانتا همزم تمدوية مخا آتوريتا خا انتربرنور بشمت غلوريا يادگار ماسيكو وهر بديدانتا بهمزم مخا inventor أمريكاية بشمت كان سالزمان همزمتن دوية بلشانة إنجلس. Hello, my name is Rebecca Simon. On behalf of Shamiram Media, I welcome all of you. Today we will be discussing a brand new invented device called the Ventilation Assistance Device, or VAD. We will be discussing this with our guest, Gloria Yadegar Maceiko, who is an Assyrian, an entrepreneur, and the founder and managing director of Silicon Valley Advantage. And we will also be discussing the device with the inventor of it, Mr. Ken Salsman, who is a nuclear engineer, a scientist who's been in the Navy, and he has come up with the idea recently. Welcome, my guests, to our show, Shamiram Media.
Thank you, Rebecca. Nice to be here.
Thank you. Gloria, I'll start with you first. Would you please tell me a little bit about your background, what you've been doing, and how was it that you came about founding your company 5 years ago?
Sure, happy to. Thank you for the opportunity to have us on your show and share our story and hopefully also this device that could be of great help to humanity at the time that is most needed.
Absolutely.
My background is engineering. I'm an industrial engineer by degree and a master's degree in industrial management. A serial entrepreneur, as you mentioned, Rebecca, have been a part of 6 or 7 startups prior to Silicon Valley Advantage, and having learned how to form companies, grow companies, and commercialize interesting intellectual property and inventions, I formed Silicon Valley Advantage, which is a technology accelerator with headquarters near the Oakland Airport in Silicon Valley a little over 5 years ago. And the formation of Silicon Valley was based on the fact that I visited my university back in Texas, University of Texas, Arlington, and saw all the amazing technologies that had been created, the inventions, the research, and decided to help my university by connecting them to Silicon Valley ecosystem. As we all know, those of us that are fortunate to be living in the Bay Area, Silicon Valley is and has an ecosystem that allows the startups to flourish. Since the start of Silicon Valley Advantage, with just the patents and research from University of Texas, we formed 8 or new startup companies, everything from devices that address cancer surgery to pH sensors, a number of what is commonly now referred to Internet of Things, sensors that can remotely give information, collect and share information. And I have been fortunate to be surrounded and was able to attract some much smarter people than myself. Ken Salsman is our chief scientist. He has an amazing background. A number of medical doctors, Assyrian and American, such as Dr. Ron Michael, Dr. Andrew Davudian, Dr. Karokian, a number of technologists and finance and business people, again, Assyrian Americans and all variety of nationalities, that has formed the team that we are now. Now we have not only been forming our own startups and our own companies based on the inventions such as the one that Kim is going to describe. We also assist startups from around the world and connect them to the Silicon Valley ecosystem to help them grow. I'm proud to say that a number of these companies have Assyrian executives and Assyrian professionals, along with our American team, Indian teams, and all different nationalities that makes us as successful as we have been.
Excellent. Thank you very much for that introduction about your company. Ken Salsman, I know you have an extensive background in scientific research, inventions, and quite a bit of background in working with major companies and research organizations. Could you briefly tell us about your background and what have you done?
Sure, be happy to. Basically, originally was trained and worked as a nuclear engineer in the U.S. Navy. Then when I left the Navy, I went back into university, did some more research, and started at Bell Laboratories, part of AT&T at the time. And I was working on some of the very first silicon microprocessors that were being developed. And from there, after several years of working on that, went to RCA Laboratories and ended up being a director of research there. And that was then purchased by GE and transferred to Stanford Research Institute. So I ended up being at Stanford Research Institute for about 10 years. And during that time, I not only managed research, but I also spun 4 companies out of the laboratory, and then decided to go with one. And from that, it ended up selling that company and going to Compact Computer. And from Compact
I
Computer,
owned one
HP.
at one time. I owned the Compact 25 years ago.
Oh my word, yeah. So yeah, we started off with that, that big box of a computer, and
Yes.
then HP came in and bought Compaq, and my research projects there were then taken over by HP, and Intel literally called me up and invited me to be a lead scientist at Intel. So I went from being a director of research to a lead scientist at Intel for several years, and started another company from that, and then that company was sold as well, and I was then brought in by the chairman of the board of a company called Aptina, and became the director of advanced technology there. And then from there, he and I got together and started a medical company. And from there, we've just kept doing it. So now I'm on my 6th company, and this thing that we started developing here was kind of a midnight dream of how to help people. So that's what we're excited to see how it works.
Impressive. Ken, the COVID-19 outbreak really happened a long time ago, but people seriously started looking at it and feeling it since March. When did you come up with the idea of this ventilation device, before or after the outbreak?
Just about mid-March, when we were starting to see the population of the hospitals and hearing so much in the news about the running out of ventilators and all the demand from the states and cities to the government going, we need ventilators, and we're people are saying we don't have enough. And I thought, what could we possibly do that was could be done in an emergency basis? Literally, how close to overnight can we do it? And then the other things we have had, it has to be simple to operate, and it had to be something that potentially could be used anywhere in the world. So I sat down and looked and said, well, what is it that I could put together that would make that kind of a system possible? And then, middle of the night, literally came up with, well, what about a scuba system? And a long time ago, I had played with scuba diving, and this kind of brought back a memory, and it clicked.
Gloria, when you look at a startup and decide whether you want to help them through their growth or taking off, How do you determine which startup to help? Because as I understand, you receive many requests. How do you decide which ones to help?
Our primary criteria is actually, like most venture capitalists, in fact, is the team. So we look at the team that has formed the company, that has come up with the new idea. We look at their background and their ability to deliver on their vision. The second thing is we look at the technology itself, whether it's a cancer drug or whether it's a medical device or is cybersecurity. And we look at the total size of the market and how big the market is. Typically, we look for technologies that we have multiple of billions of dollars of market. And then the third thing is the actual protection of the idea, which is the patents. Um, and then the fourth and very important thing for us is to look at our team. We're fortunate again to have 60 plus technology professional advisors that look at the technology. And if we have the expertise that can be of assistance to that company, if we understand and know deeper than just the surface level about that technology, then we usually take them on. And the other really important factor for us is our energy level with the team. So if they we have a common culture, if they have the attitude of teaming, if they have the attitude that a team is greater than the individual themselves, and can work in a teaming environment where everybody contributes and plays on their strengths, then we usually select them. And this has been an amazing experience, particularly when we bring companies from overseas. Silicon Valley Advantage is fortunate to have an agreement with the Ministry of Science and Technology of Taiwan. We look at over 100 startups from Taiwan that have great amount of research and scientists and engineers, and we select somewhere between 5 to 10 companies into our program as an example.
Only about 5 to 10% only.
Yes.
Gloria, I'll ask you a very basic question, and it may be a funny question, but I'll ask it anyway because it crossed my mind. With you having 25 years of experience in engineering and startups, does your intuition come into play at all when you're picking a company?
Absolutely, every time.
It wasn't a funny question then, was it?
It wasn't. It's a perfect question. We're all fortunate to, of course, our intuition is largely based on our experiences, but a big part of synergy of teams is intuition, right? Is our personalities, are we a good match with the team we're taking on, and they're a good match for us? It absolutely has to be mutual. But that was a perfect and actually scientifically proven question that intuition plays a big role in all of our lives, and certainly in technology, and companies are no different.
Absolutely, and I think intuition is fine-tuned as we get older and become more experienced and wiser.
Absolutely. Experienced and wiser, I go for that.
Very well. Ken, so what is the difference between your ventilation device, VAD, and the regular ventilations that are being used currently at the hospitals to save COVID-19 patients and of course, other patients?
That's a really good question, and I think we've got a picture that can show you the kind of the comparison of the two. But basically, the thing that you see when you go in the hospital is like this vertical stand-up unit that can roll up to a patient's bedside, and it has a lot of electronics. It's computer controlled, and one of the things it does is it hooks up to the oxygen supply that's built into the hospital, and then they apply either a face mask or what they call uh, a tube that then they'll put down into the lung of the patient if it's very serious. But these machines aren't designed to help you breathe, they're designed to make you breathe. And so it works great for someone who is a critical patient who really has lost the ability to breathe on their own. This machine will go in and force air and oxygen into their lungs and let them exhale. But it basically does both. It forces air in and it pulls air out. So it helps you, it really makes you breathe. There are what they found talking to a lot of the doctors that we're working with, well, the doctors saying, well, there's a lot of patients, in fact, a majority, that are being put on these machines that don't need the full capability because they're able to breathe on their own, but they're breathing shallow. What they need is more oxygen in their lungs, not to be forced to breathe, but to let them breathe normally. And in fact, they were actually afraid that the ventilators that are being used actually can injure the lungs. So that's one of the reasons when we designed this, we were looking at what we call a very low pressure. So we're not forcing air into the lungs at a level that it could actually, potentially if you've got weak lungs and you've got infection or something like the COVID-19, your lungs are very easy to damage. And so this system we've developed doesn't put enough pressure for you to have that kind of risk.
How much does your unit cost if you market it?
If we put it together, it's probably about $500. It really doesn't cost very much. I'm sorry.
How much does a regular, more advanced ventilator cost?
The lowest cost one I've seen so far is around $5,000, and the most expensive about $50,000. So they average around $25,000. So this is a significantly different price range than what doctors and hospitals are used to being able to deal with.
Gloria, is this device patented?
It's patent pending, yes. So as you asked and Ken answered, he only came up with the idea in the middle of March. We started experimenting with it immediately. We reached out to a scuba diver master that knows how these scuba diving regulators work. And Ken started coming up with the drawing and the idea of how to modify it. So at that time, yes, we filed the patent. So at the moment, it's patent pending.
But can you manufacture it now and sell it? Even
Absolutely.
though the patent is pending?
Yeah, absolutely. So all patent does is it doesn't prevent you from manufacturing it or selling it. It prevents competition from copying your idea. That's the only advantage, really, of having a patent. And since this is what we hope to be a life-saving device, we're not really too focused on the patent side of it, although we do the smart business thing by patenting it. However, again, the scuba diving manufacturers, which we have contacts with and distributors, have hundreds and thousands of these devices that they sell as scuba diving gear. And we have our own 3D printing, and in fact, our office in Oakland has the capacity to 3D print large amount of these connectors that we need for the device. So Ken 3D printed his own attachment to it. And the mask and the hose are just standard mask and hoses that hospitals have and are commonly used. So to produce hundreds and thousands of these is rather doable literally within weeks, which is one of the other attractive parts of this device is inexpensive, is easily available, is easily manufacturable, and because of its portability, then also we're easily able to ship it around the world. And as you think about this particular virus, what the world is living with, our goal is to make this as available as possible to any economic level. Not every country is as fortunate as we are in US or in Europe or Australia. So for the developing countries where hopefully this pandemic will stay at a manageable level, nevertheless, buying $25,000 ventilators for massive millions of population is just simply not doable. And so this makes it much more accessible to globally to even developing countries and countries that don't have the kind of economic power that we have.
Yes, with millions of people around the world being infected and a great many hospitalized, this device can take some pressure off hospitals and releasing some of the more major ventilation systems. So this can be used. How are you planning on marketing this, especially internationally, since the cost is so low in comparison with the regular ventilators?
Well, we're fortunate, like other medical devices that and companies that we assist, we do have that reach. We are a member of a nonprofit group called Biocom. They're an amazing organization in California that assists startups and connect them with larger medical companies. So we intend to connect with large distributors and manufacturers of medical device companies. We have some of those contacts ourselves, again, based on other companies that we have been working and helping. The other part is also through hospitals. So we have contacted a number of doctors that we know at places like Kaiser, at UCSF, at Stanford, at Sutter Gold, and we have connections in the East Coast, in New York, in Wisconsin, in Illinois, where Dr. Michael is. And so we're reaching out additionally, in addition to hospitals and medical devices, also to the governors of these states. As you know, the governors are heavily involved with trying to manage this pandemic in their states. And what we're hoping the government and governors can do is speed up the emergency use of this device and speed up the process of FDA approval for it. Because without the FDA approval, other than a trial, which the hospitals are allowed to do if they choose to, we're not going to be able to sell it globally. At least in US, we cannot sell it without FDA approval. But we're very much working on speeding that process through the governmental organizations.
I know the device is brand new, just fresh off the Ken's inventive mind. But have you had any responses yet from anyone showing any interest in acquiring some of these units?
Yes, we have. Again, the doctors that we have reached out to, we've had some very positive responses. And they're going through their own hospital process to get approval to try it. And so we're literally in that process because this whole piece, the whole device came together with the 3D printed piece, with the mask, etc., literally last week. So this week has been the first time where we've approached these larger organizations. Biocom today, in fact, is putting this on their website. And so this week and early next week, it should be on the Biocom website and largely viewed by about 1,300 medical member companies that they have.
How long does it take for the FDA to approve a patent, on average?
Normally, an approval of a medical device is 2 years, but as we've all seen on the news recently, a lot of these discoveries are being speeded up quite intentionally and with the right attention to it. So we're very much hoping, again, with the governmental connections and governors being involved, that there is an FDA process for emergency authorization use, and that's what we will be using.
Hopefully. Ken, I'd like some comparison between the hospital ventilations and your device. How much do you know how much the hospital ventilation weigh and what the dimensions are versus yours?
There are a wide variety of the machines. Most of them, as you saw the picture earlier, is on like a roller cart. So those machines can weigh, many pounds, probably 50 pounds, or in some cases, maybe more. But I don't have an exact figure for the weight. But one of the big problems is, yeah, they occupy a reasonable amount of space. The real one of the real differentials that is a problem in this kind of a situation where we have so many people that are sick that they're filled up to hospitals and even out in the hallways, and now in some cities they've have hospital beds in parks. Um, is that it's a strain on the experts, the nurses, the doctors, all the medical care personnel, to try to handle every patient and see what they're doing. And these standard medical ventilators require expert use. You have to be trained and know in detail how to operate them, because you're pushing a fairly amount of pressure into the patient. You got to make sure you can control how much, make sure what the breathing rate is. So there are a lot of variables that have to be understood and programmed into these things, and that makes them much harder to use in general.
And how much does your device weigh?
I didn't actually weigh it, but it's probably on the order of I don't know, somewhere between 3/4 of a pound, maybe a pound. So it doesn't weigh very much at all. It's the kind of thing you could actually lay on your chest and probably in a minute or two, not even realize it's there.
Very well. that's great. Is it easy to use? Can a patient use it on his own without, unlike the regular standard ventilations that experts have to use them, experts who are specialized in using ventilators. Can a patient use this on his own?
Yes, actually, it's one of the things when I show you here, and I give you a little quick demonstration. It is actually very easy to use. So you can put it together in a matter of seconds. And,
Yes, please give us a demonstration.
Okay.
We'd love to see how it's
Sure.
used.
Well, let me show you first. I'll show you this little thing. This is the standard mouthpiece that people think of when they think of scuba equipment. And that fits, right in between your teeth and whatnot. And it works great when you're diving underwater, but it's probably not the thing you want as a patient laying in bed. So that's one of the things we removed. Um, but if you look at a standard regulator, so this is a diving regulator that you would think about, when you see a scuba diver, they would be using with this, in their mouth with the mouthpiece I showed you. We've gone inside the unit here, and inside the valving system, we've actually made modifications, because one of the things, when you're diving, you're using a lot of high pressure gas, so a lot of oxygen that is under a reasonable amount of pressure, like 150 pounds per square inch, which is a lot. Your atmosphere is about 14 pounds per square inch, so to give you a comparison. So a little more than a factor of 10 difference. We've redesigned it to handle 50 pounds of oxygen from the hospital gas supply, and then this drops it down to just barely above atmosphere. So literally, see if I can give you a comparison. The amount of inhale energy that you have to put for this to operate is 0.03 pounds per square inch, which is I think I figured out is about the equivalent of a stack of 10 $1 bills. And that the weight of that is all you have to be able to generate with your mouth to cause this thing to trigger and give you oxygen. So you can take this. This goes into a standard hose that goes into the oxygen outlet in the wall of a hospital room. This is the way the equipment comes. So this adapter has replaced the mouthpiece. You have a standard hose, which is the ventilation hose that you use for, say, a mask or an intubation tube. That hose plugs right in like that. So if you plug this in the wall, you plug the hose in there. And if I get the other end of this, which fell down, you take that You take your mouthpiece, you slide it over, and you put this on and start breathing. It's that fast.
Amazing. That's wonderful. The ease of use and no risk, almost no risk, right? Because it's low pressure oxygen.
It's low pressure, so we eliminate a lot of the things the doctors have to worry about on the ventilation systems of having a program when you breathe. This is really designed for you to be able to, inhale just a little bit, enough to trigger this thing to say, okay, here's the oxygen you need. And when you exhale, the valve automatically shuts and lets you exhale naturally. So it's a minimal amount of force on the lungs.
Do you foresee modifying this unit so people at home can use it? People who have asthma, people who have panic attacks. Do you foresee that?
There's a wide variety of applications for this once we start looking at what people would really want in that. There's even some capability. There's the front of this is a button, so if you need to force yourself to breathe, or if somebody comes up and sees that you need more help, if you press that, you can then actually add a little bit of pressure, just a little bit, to help someone breathe if they're having problems. So yes, this will work potentially for a lot of different issues that people have. It also is sealed inside, and one of the things that's very good is normal. A lot of the rebreathing systems, or the kind of the ventilation assistant devices, the vent actually just lets the air out of your mouth when you exhale go right out in the room, right in front of your mouth, your face. And that's one of the ways that the current medical people are scared to death of the patients, because if they've got COVID-19 and the mask they're using allows them to exhale right out into the air in front of them, then they're exposing the medical staff to the COVID-19 every time they breathe. This will vent, but it vents to the side and down, and there's a large room of circulation inside here. So any particulates like saliva, things like this, or what you might breathe out that is any kind of particulate matter, will stay inside the unit by and large. So very, very little of that is going to get out. And when it does, it's going down and away from both the patient and the medical staff.
Very good. Gloria, what is the capacity for you to generate? How many can you generate if in case this thing gets known throughout the world and the demand becomes very high? Do you have a great capacity to produce as many as you can? Because you can't really 3D print hundreds of thousands of these.
Right. So our goal is that to produce several thousands of these rather rapidly and get them in the hands of people that need them as fast as possible. But beyond that, we're going to work with the manufacturers of these regulators. As Ken just demonstrated, there is a modification inside the regulator which the manufacturer can make. And the piece that needs to be added and modified, it's rather can be produced in hundreds and thousands in a mold injection fashion, and so therefore it does not have to be 3D printed. So the answer is yes, we will partner with the manufacturer of the regulators to really do this. We've already reached out to them, at least in Taiwan, where we have great connections, and it's been one of the exemplary countries that managed this COVID-19 and this pandemic extremely well. And we will work with US manufacturers to do the same. So, and then as far as the distributions, is really the medical device companies that have the large reach globally to be able to distribute them. As a smaller company, we don't have that reach, but we always work with larger partners that do.
Do you know,
Rebecca, I could say,
yes, of course, Ken,
I could
please.
give you one other piece of information too. Is scuba equipment like this, give you an idea, there's around 3 million registered scuba divers in the United States alone, and there's scuba divers in every country. So if in an absolute emergency, we could probably take at least a reasonable percentage of the existing scuba equipment, make the right modifications, probably in as little as in half an hour per unit, and then apply the adapter, and you would have that many units. Could be literally hundreds of thousands in weeks.
So in 30 minutes, you can modify a regular scuba equipment into this
If you have a
device?
if you have a person that's trained, and we could train those people as to how to make the modifications.
A question comes to mind as far as the patent. Do you think this patent will be granted if the device is so very close to the scuba equipment?
It uses the scuba equipment in a different way than it's designed for, so that kind of modification is what we filed the patent on. So it's not only just a little adapter on the mouthpiece that would be hardly worth a patent, but it's actually readjusting from a system that's designed to operate at like 150 pounds per square inch to a pressure that's literally 50 pounds per square inch. So basically 3 times less. That is something that scuba equipment by itself without modifications can't do. So those modifications help us do something unique.
Right. Can I believe it? I'm correct in stating that there is such a thing as application patents. So one can take an existing device such as this one or a number of others. When you use it for a different application that it wasn't meant to when the device was made, that it becomes an application patent, and that's what we have filed.
Very good. Gloria, you are dealing with quite a few of startups. And how much time personally do you spend working? And how well do you sleep at night knowing you have all these companies under your wing and you want to make them fly? And do you worry a lot?
I'll answer your last question first. I don't worry.
Okay, good.
I don't have time to worry, and I don't think worrying is a positive, necessarily positively contributing factor in building companies. One has to be wise. We all work very, very hard. I don't encourage necessarily anybody to live their life as sort of our life is at the moment is pretty not balanced. We are working between Ken, Manny Singh, our chief marketing officer, somebody like Dr. Ron Michael that has been hand-holding us through this particular one, as well as a cancer research company that we are bringing to US from Taiwan. We have a patented technology that is delivering cargo to live cells called Tana Therapeutics. We're all working a good 12 to 16-hour days, including weekends.
Worrylessly.
Yeah. but when you're passionate about what you're doing, even though physically at times it gets no doubt tiring, we all go for our walks daily, and but we are such a supportive team of each other that I think we draw on each other's energy. When one of us is lower on energy, the other picks it up, and so we balance each other so well, and we're really fortunate to just have the team that we do, because everybody does more than their fair share, everybody does more than their part, and so it propels all of us to do it and do it well. Hopefully after this pandemic, we all get to get a little bit of a rest, maybe a little bit of vacation would be nice. But right now, when it comes to doing something so critical for the world, it's not the time to worry about ourselves and how hard we're working. It's time to worry about others and taking care of others, because we're fortunate and we can.
And especially when the corporate staff becomes a family unit, then it's far easier to work harder towards a common goal because there's a cohesive group that's working towards the end.
Absolutely.
Ken, can you tell me about some of your inventions? I think you've had over 120 patents, right? Am I right?
Yes, I have quite a few.
Give me some
So,
of the famous ones that our viewers will say, I know that product. I've used that product. I've heard it. I've seen it.
one of the most dangerous ones is probably the Wii remote control for a video game. So there's been a variety. So everything from things that are used in your cell phone to things that have been used in microscopes for medical use, as well as a number of other things. So yeah, I have a fairly eclectic background, and I've applied physics and what I know to a wide range of different kinds of products. But yeah, when I was at RCA working on television systems and displays and video cameras, and then since then working with companies like Intel, where you're doing very unusual things or creating new kinds of computing systems. And in fact, the last couple of years, I've been doing a lot of work with autonomous vehicles and what's called edge computing. So yeah, it's things are happening, and it's a lot of fun. Keeps me occupied.
If I want to quote a famous saying, need is the mother of all inventions, how do you get your inspiration for your inventions?
It's kind of like what happened in this one. I will see a problem and think about it a little bit, and sometimes it's in the middle of the night, sometimes in the middle of the day, whatever. Things will start clicking. I'll say, well, if I use this, and this, and apply them, I can actually see how to make that that thing happen, that device work, or create something brand new. And usually, the things that actually make the difference are things that are not a light year away in technology. They're usually, what can I modify with what I already have in my hands, or very close to being able to have in my hands. And a lot of times, one of my old professors was known for telling everybody to think outside the box. And then one day he looked at me and said, "You haven't even found the box."
Well, I'm sure if you have a genius mind, coming up with inventions and ideas is not so difficult.
It keeps me occupied. It takes a little bit of work.
I'm sure it does.
The other thing is that as we sort of, again, we're fortunate to see so many technologies, so many startups. We know the trends. We know where venture capitalists are focused. We know kind of the needs of the world and what has large markets. Often we actually go to Ken and say, hey, this problem needs to be solved. Can you find a solution? And so far, as long as I've known Ken, which is well over maybe a year and a half, he hasn't said no to any problems we've brought to him. So he's just the most amazing problem solver.
Ken loves problems.
Yes, yes.
To solve them.
The challenge for him is there is no problem that he cannot solve.
Very well.
Right?
Ken, writers have writer's block. Do inventors have inventor's block sometimes?
Oh, most definitely, most definitely. That is the smile disappears and a frown appears, and you get really frustrated. But yeah, there are times where you just look at something and going, "This is a problem that should be solvable. I just don't know how to solve it." And that's where your network of people that you know in the fields, the different scientific fields. Sometimes the best person is to go find someone that has no idea about what you're working on, explain it to them, and then watch what happens. And being the father of 5 children, I had 5 what I called expert witnesses that I could explore things with and say, "What about this?" And the wonderful thing about kids is they don't care how embarrassing the answer might be that they're going to give you, but they're going to try to solve it. And I learned a lot from having that environment around me.
Very good. 5 children, my goodness, and you're still inventing. You invented 5 at home and invented 120 outside of home. Very good. Gloria, what is next for you? What is your plan for future, for your company? I know you have quite a few Assyrians working. Do you have any? I heard that you have some plans for Assyrians. You're very passionate about Assyrian causes. Tell me a little bit about that.
Yeah, what I'm very much hoping and working towards, taking steps towards, is as we bring these companies, or as we have these amazing inventors inventing different things, I seek Assyrian professionals that have expertise in a certain area that can become a part of these companies. They don't necessarily have to be the inventor, but they have the professional and the knowledge, the skills to help us build and grow these companies. They have the reach, they have the connections. So I brought several examples already. For example, there is this wonderful chief financial officer type, Ramin Zakaria, that reached out to me. He had heard about Silicon Valley Advantage and wanted to be able to participate in these startups. And now he is our chief financial officer for the ASH sensor, the structural health sensor, that then again is Ken's invention. And it's one of these Internet of Things devices that we can put. Is literally the size of a capsule. I don't know, Ken, if you have that handy to show, but it is, we can easily put it inside the concrete as buildings are being built, bridges are being built. There it is. That's it. It's literally the size of a capsule. And it has the wireless capability of detecting cracks and detecting problems inside the building, and wirelessly disseminate this information. So as soon as a problem develops, before it becomes a disaster, before a bridge falls down or a building comes down or a whole wall comes down, that it will detect the problem and report it immediately, so it can be fixed and not become a disaster.
That's already invented and patented? That's patented?
Yes, definitely.
And the patent is approved?
Yes, one of them is, yes.
Yeah, one of the patents is approved, the other one is pending. And Ramin reached out to us, and he is a chief financial officer for Ash Sensor, and we are raising funds for that company. It's a pre-revenue, again, it's a fairly new invention. And so Ramin is helping us reach out to construction companies, to companies that are involved with technology for construction. And so what I'm hoping, again, these kind of interviews and the word getting out to our community, where for this medical device, this ventilation assistant device, I like to ask all the Assyrian doctors, Assyrian nurses, medical staff, people that are working in the front lines with this pandemic, to reach out to us. We'll be happy to help get these devices into their hands if they want to try them, if they want to show them to whatever hierarchy of their organizations they're working with. Same thing with the ASH sensor. I invite Assyrian construction companies, Assyrian structural engineers, Assyrian American, any nationality, to come help us. We need the connections and we need the professionals to help us achieve this. So my goal, back to your question, is the more Assyrian professionals are a part of this structure that we have come up with that help us build these companies, we share the equity, the actual stocks in these companies with these professionals and executives that help build these companies. And what I hope to achieve over the next 5-10 years is several of these companies to have a nice exit, $100 million exit, $500 million exit. Some may be more fortunate than that, yes. And bring the economic level of all Assyrians around the world higher, because there's the economic power that gives us the power to help our nonprofits to help our people in need and those in diaspora. That's what I hope we can get to in a few years.
We desperately need that because over centuries, we are a people who have been massacred, run out of our homes. Sometimes families have migrated twice in mass exoduses because of the genocide. And that's why we are, as a nation, a tad underdeveloped and not as affluent as our ancestors used to be. So any means by which we can prosper is very much appreciated. Ken, I'd like to ask my last question of you. Is your fertile mind cooking anything? Any new invention you're thinking about? Not that you have to tell us. Just say yes or no.
A couple are usually percolating around. One thing I've learned is the longer you let something percolate and stew, the less likely you'll come up with a bad idea.
Ah, okay. Keep working at it. It's very nice to meet you. And
It's a
Gloria,
pleasure.
I think, is there anything else you'd like to say? I know you've said what you wanted, but is there anything else you'd like to add? I know you had an inspiring quote yourself that I want you to repeat as your last word.
My
You shared
inspiring.
it with me once. You want to
You have.
make your own?
Oh yeah, definitely your own destiny. I'm a big believer in that. We always have to be at the right place and the right time, and again surround ourselves by very smart people. But at the end of the day, we can't let others control our destiny. We should try to control our own destiny. And I also like to say one of the projects that Ken again is helping us with, it started somewhere else with a technology that actually came from South Carolina, but we are in process of forming a new company for intelligent traffic lights. As you know, traffic lights are everywhere. We all deal with them as
Yes,
we
we
drive.
know.
And
With
we're,
cameras sometimes.
yeah. But those cameras, the security cameras, the way that we're developing the intelligence with the around these traffic lights, especially with connected cars, with autonomous driving, that's one of the projects that we're also getting off the ground. And I like to say in this area, and if I may, بسنت رابا ربecca قد دانا قد ولفتن همز مفمنوخون قد ماطف الآتورای خينة قد أبي خيرانه يا قدن companies قد برايخ يا آتي خوتي بكو experience professional knowledge قد اتنون قد خلد على بهايارتت على بهايارتت سيراي خينة ما دخل دانيشة قد كل سويراي ماضي خا دوكا قد أمسي عبي خيران قد كل ملته.
Čim دوز اويت رابا باسنتا غلوريا إن شاء الله كدونا اويت منتينتا وبياين مزيدا خبري خارا يا آها أفي قديخ وقا قشقانت يداءت شميرا. Let's make our destiny and let it be pretty. أبيتون رابا باسيمه.